Right, okay, thank you. And well, I guess welcome to Manchester. So I'm Alastair Basden from Durham University, also part of DiRAC, which is one of the UK national facilities funded by STFC, the Science and Technology Facilities Council. So I'm going to be talking a little bit today about what we use for Lustre in DiRAC. We have HPC systems at 4 sites, so Cambridge University, Durham, Edinburgh and Leicester universities. Several of these systems are in the top 500, so some of them are fairly sizable. Now, basically a summary of what we have. All of these systems use Lustre. Hasn't always been the case, but now, as of now, all of them use Lustre. So in Cambridge, for example, we have 8 Lustre file systems, totaling about nearly 5 petabytes of data. There's more than that in Cambridge. This is just the quota that's available to DiRAC. In Durham, we've got 7 Lustre file systems ranging from fairly small up to about 7 petabytes, about 16 petabytes in total, and 2 fast scratch file systems, which I'll talk briefly about. Edinburgh, 2 Lustre file systems, 3 and 4 petabytes, DDN appliances, and in Leicester, again, 2 file systems with various different variations of Lustre on those. Now, I know most about the Durham Lustre file systems, so I'll talk a bit about them here. So you see there all 7 file systems, and what I've done, what I thought might be of interest, is I've separated them out, the number of metadata servers, metadata targets, object storage servers, and object storage targets. And also what backends we use. So we use a range of LDiskFS and ZFS in various different places. One of them, this one here, COSMA 5, can't see that very off, has a ZFS metadata and object storage. Most of them have LDiskFS for the metadata and ZFS for the object storage, though not all of them. At the moment, they are all on Dell hardware, and they're all systems that we build ourselves. So we buy the bare servers and the bare JBODs, etc., and install Lustre, configure Lustre on top of those. Our experience, I guess probably a lot of people say this, it's mostly stable. It's certainly powerful. It certainly most of the time does what we want it to do. Though we do have it does sometimes wake us up and let us know that it's there, should we say. Some of the features we think could be improved. So in particular, the PFL, progressive file layout implementation, seems to me there's something not quite right there. If you set up a nice PFL layout on your files and someone writes a large multi-terabyte file, you end up with some small fraction of that on your metadata server and some break. If it doesn't, I would expect it to sort of break itself down a bit more intelligently. What we also find is if we put PFL across the file system, then actually the file system will start to hang if users run an LS on a directory or something like that, just because it takes so long for it to gather all these different PFL components and so on. So that really was tending to slow the file system down. Mirroring is also another feature that I guess we would like to see improved. It relies on the user to actually do the mirroring. The other odd thing is that if the users don't know about using pools and they're just following instructions, then both copies of the data can actually be on the same disk. So that again, some slightly more intelligence there would be something that we would, I guess, like to see. Some of the tools appear to have been forgotten about. I don't know if anyone remembers IML. Hasn't been touched for a few years now. We've never actually used it, partly because it was when we discovered it, it looked like it was already sort of abandoned. Some of the documentation is slightly ambiguous, I guess. I mean, it's always very difficult writing documentation, but there's we have come across some ambiguities in the documentation there. It also this is our experience. We generally think the file system knows when it's Friday evening or Christmas Eve and reacts appropriately. So the setup actually we find is relatively straightforward. If we want to commission a new Lustre file system, generally speaking, you can follow the instructions and it generally works. There are, however, lots of fine-tunings that can be made. Not all of these are suggested in the same point. You often have to know that they exist or be reminded of them or search through the documentation to find them. And the default options also most likely are not always the most sensible. Perhaps they were 10, 15 years ago, but perhaps things have changed and are not Now, one of the other things that we've spent a lot of time doing is optimizing and balancing SAS channels. Now, this is so we've got a picture here of one of our JBODs. So you fill it up with rows of disks. Some people might be familiar with this type of thing. And this particular drawer, there are 2 drawers like this per JBOD, 4 SAS channels. And the disks, if you want to get your best performance, you kind of have to balance your disks along the SAS channels. And what we found out, just nowhere in the documentation, but through trial and error, is that on some of the SAS channels you've got 14 disks, and on other SAS channels you've got 28 disks. So when we take that into account when we're building our Z pools, etc., to make sure that we try and balance that, so that if you're writing or reading to a Z pool, you're not always reading and writing to the same channel, you're balancing it over the channel. So we now have nice scripts that kind of do this for us. So that was just something that we had to put effort into to look at. And I wouldn't expect, I think, Lustre to know that, because obviously it's very much hardware dependent. But if you are building a system, it's something that's worth taking into account. Right, we have, I thought I would talk now about, since lots of people here use Lustre, you might have similar problems, you might have different problems. We have a number of current problems. None, of course, are showstoppers. The system is generally up and running reliably. Some are inconveniences, some are a bit annoying. So one thing we found, we were trying to remember whether this is a recent change or whether it's always been like this. We think probably it's a recent change in 2.12. But if you try mounting your metadata targets, they usually hang until the object storage targets connect, or wait for 25 minutes and then time out. Now this is obviously some sort of recovery window. Can be problematic if an OST is unavailable, or perhaps whole OSS. So that's one problem. This is kind of an annoyance. It means that we can't bring the system up quite so quickly, or we have to, if there's some component missing, or we're trying to investigate a problem. Quotas. This is always a mystery to me. Quotas occasionally seem to be ignored, and occasionally we'll find a user who has gone significantly over their quota and still able to write their files. And we haven't really got down to the bottom of why this is. It just seems to happen occasionally. Perhaps thinking about it, perhaps it's happening less frequently now than a year or 2 ago. So perhaps as we've updated, these problems have been fixed, but I think it's probably still there. Dual IB routing. This is one of the problems that we had on one of our fast NVMe storage servers. So at one point we had the file system was probably the fastest in Europe. We now have one of the file systems writes about 400 gigabytes per second, so pretty fast. And what we do for that is within our servers, there are obviously dual CPU servers, can be connected to each other, each one with 4 disks attached, and the 2 InfiniBand interfaces. So what we've done is we're basically trying to route our traffic, these disks through the CPU and out through this interface, these ones through here and out here, rather than doing the opposite way. You might have your data routing one CPU to, that's what we're trying to avoid. What we find here is that when we're mounting the file system, when we bring the file system up, occasionally a group of 4 disks will write to these group of 4 disks will fail. And those, they get marked as down by the clients, and you can't write to this. It's not always the same 4, so it can be on any of the servers, usually on the second CPU of a server, but not always. But it's always on one half, the ones that share a particular IB link. Eventually, rebooting the servers enough times fixes this. We think it's probably something to do with LNet routing. We haven't managed to find a fix yet. And well, it's less effort to keep rebooting the servers than find a fix, I guess. So that's probably our fault. But it's anyway, when it eventually comes up, it then works very nicely. But it is now something that we check every time we bring a file system up that all the OSTs are writable. The speed. We occasionally get incredibly slow file access. This seems to be when loads on one of the OSSs goes very high. Possibly due to underlying contention in the OSTs. But when we look at this, when we're trying to work out what's happening, the I/O rates to this actually seem fairly low. So we're not sure what the problem is here. We then try and persuade users to direct their new writes to alternative servers, just to help the load come down. And since we've turned off PFL across this file system, this problem has gone away a bit, but we think the PFL definitely didn't help. And because that significantly increases the file system load. And of course, when a file system starts to chew up like this, then users try to do more LSs and things like that, and it tends to get worse and worse. Data loss. We have actually had some data loss. This was on a new file system. It had only been in production for about a month, just about a year ago. And this was not really, I suppose, a fault of Lustre. It was more the underlying ZFS. We had, well, with the multi-mount protection, I think, kicked in. It led to one of the OSSs killed and stone-ithed another one, and that stone-ithed itself, and things like that. And actually, we ended up getting corrupt data on the ZFS file system. Now, if you read all the documentation, that shouldn't be possible. So we think actually there's, and we did look we spent a lot of effort trying to work out what was the problem and how to fix it and so on. We think there's a bug in ZFS 079, which is the one that you use with Lustre 212. It's never happened again, but it's something that we're a little bit nervous of, and so now we're much more careful with our pacemaker. We basically turn pacemaker into manual mode, which I think is probably the way that most people, if they've got any sense, would use pacemaker anyway. Right, one of the problem here we have is very occasionally on the ZFS metadata targets we have kernel panics. I think it's only happened twice, 3 times, something like that. It is a known bug. That we haven't had a backport for it yet. Again, this is some interface between ZFS and Lustre. Not quite sure what it was, but again, when it happens, it's not very nice. You have to reboot the whole file system. Yeah, we occasionally get Z pools being suspended, mostly due to multi-mount protection. So this is one of the things. I guess there's a lack of the integration between Lustre and ZFS. Again, comes down to, I guess, sensible defaults, things like that. And we can get around this by increasing some of the timeouts, and that seems to fix it. But as with all these things, timeouts only fix it in most situations. So we can't say it's completely fixed. Yeah, we have a weird situation at the moment, which other people don't seem to have, but seems to be specific to our combination of perhaps CentOS 7, the version of Lustre, perhaps the version of the InfiniBand drivers, etc. But we have this deterministic instability for client-server versions newer than 2.12.6, whereby if MPI job is running and it runs out of memory, and then it gets zoomed, tidying up fails, the InfiniBand somehow gets upset, and basically the Lustre client gets in a position where it's basically stuck, and the only solution we have to that is rebooting the client. So that's a bit of a weird one. We're not exactly sure, but it seems to be that some code introduced in 2.12.7 and beyond means it doesn't clean itself up very nicely. Occasionally, this is another annoyance, I guess, if we use multi-host, multi-rail clients. So we've got the InfiniBand and the TCP. Occasionally, the InfiniBand mounts, we find that they've been remounted as TCP, and you do an LCTL DL minus T, you get for TCP, and sometimes they shouldn't be there. And the only way we find to fix that is unmount the file system on the client and remount it. It'd be nice to be able to do that without remounting, because obviously if there are things going on, it'd be nice to be able to redirect them. And we think it's probably if a particular OST becomes unresponsive, or OSS even, it makes the client think that NID has failed or something like that, and tries to do the sensible thing, but it'd be nice if it was able to revert back. We also randomly see 1 or 2 codes that we can more or less reproduce. SIG bus errors on compressed ZFS backends. Not quite sure what this is, but obviously if you're trying to memory map compressed files, it does get a little bit difficult. Yeah, so there we are, summary. Lots of file systems are in use across DiRAC, and we've got within the DiRAC teams, we've got a lot of experience. I wouldn't say we are necessarily an experienced team. We sort of muddle along and do what we can. We don't perhaps know the file system as in greater depth as some people do, but we probably have enough information to work our way through most of the problems that we see. And mostly it works well, but there are some niggles. So. Thank you.